We got all the selection options, and we have to talk about converting value types, because as you saw before, when I connected a normal to a density output, the density expected a float, and the normal wasn't a float, and it gave me an error, and I can still see it there, even though it's probably not so important. So I'm going to delete everything. Actually, I'll close this and start a new scene. And in this scene, I'm going to convert, first I'll create a plane. Where is my plane? Here's a plane. I'll create a plane. I'll create a PRT volume out of it. I'll give it a little bit smaller spacing. And I'll add a magma on top. And now I want to create a color. So Shift Control C, I have the color output, and I want to connect to it input channel called index. The index is the actual internal counter. We have an implicit loop over all the particles in the stream, and this counts from 0 to the number of particles minus 1. That means the first particle has a value of 0, and the last one has the number of particles that were generated, minus 1. And I want to create a color based on that. So it would be a gradient going from black to white, for example. Now, it tells me immediately that I cannot do this way because this index is an integer, and I need a float with 3 components, which is a vector, which is a color. You'll notice when I select an index channel, I get automatically those shortcuts that I mentioned, conversion shortcuts. The one allows me to do to float easily, and the other one to clamp the value between some minimum and maximum values. I'll press the to float, and this inserts a new node in the flow, but that still doesn't help me because now it says it's a float 32, but I need a vector. But this toFloat has a toVector operator, so I do 2 conversions, integer to float, float to vector, and now I have something that looks red. And it looks red because all the values, except for the very, very first particle somewhere, which is black, all the other particles will have a value above 1, and that gets shown as clamped at 1, so it's red. I have to obviously divide this by the number of particles approximately. I don't know exactly how many particles I have, but I'll try 30,000. And now I gotta start getting something. I'll go to 50,000, and that's probably closer. Let's try 40. That's good. So that means that somewhere in the beginning here I have the 0 particle, and there I have the 40,000 particle. And now I have a gradient. And if I select this guy and press spacebar twice, the output of this will be connected to the red, green, and blue, X, Y, and Z, inputs of the two-vector conversion, and I get my gradient. So conversion is generally very important. If I don't convert the integer, the index integer, to float before passing it to the divide, the division won't look very nice because integer divided by another integer doesn't produce a float within Magma. It's going to produce a clamped integer, so most of the time I'll get 0. And that's not what we need. So this divide shouldn't be happening here. If I remove it from the flow and add the division here, and say this will be divided by 40,000 as before, right now it's not even compatible because this type is float and this type is integer, and it doesn't like it. I have to switch this one to integer, say 40,000. And when I divide, it doesn't produce any white anywhere. It produces only black. If I divide by 20,000, I get up to here black and then white. So it's very important to do the conversion first, do the toFloat, switch this guy to float so it divides correctly. Did I add the right thing, the right place? So integer, this guy goes to float, this guy divides by this, then we don't have a toFloat here again. This is the correct way to do it. You will be responsible for most of the conversions of channels. When you want to get something from a vector to a float, you can break out, and you see very soon how to do that. And integers have to be converted to floats, and floats have to be converted to vectors, and so on. Getting scene data in the current, or the version that I'm currently showing, and which we hope to post today, is much better than it was in the original version of Magma that we posted. And I'm going to show you what we changed and how much better it got. We already have a tutorial online for the original way, which used expressions in Maya. So if I create, for example, once again a sphere, and fill it with particles using a PRT volume, and then add a magma on top. Let's say that I want to set the color. to the position, and that gives me kind of fancy colors here because the RGB, the XYZs are converted to RGBs. But as I mentioned, there is a special operator that's, oops, I wasn't here. I want to press Control R, and this is now in branches ordering mode, so anything that I insert will automatically reorder the flow. I want to break out the X of this vector, and right now I'm taking position, take the X, output, well, that doesn't really work because I need it as a vector, so add conversion to vector, but this doesn't help me either because it's not really changing anything. The X goes to X, the Y to Y, and the Z to Z. So if I press Control W here, you see that the first two input sockets got swapped. So now I'm outputting the X as Y and the Y as X. If I want to swap the Y and Z, I press Control Shift W. They are also here, so you can see them. Swap the first two and the second two. And this changes things, but what I actually wanted to do is I'm going to disconnect most of these guys. I'll say connect this one to the X, and then connects this one to the Y, and pretty much the first input is now connected to all three. That gives me black on the negative side of the sphere, and on the positive side get white. And a little bit of gradient here within 1 unit because it goes from 0 to 1 and then stays above 1. Now, obviously, we would like to divide this breakout value by the radius of the sphere approximately. I don't know what the radius is right now, but if I start changing this value, I'll see that at some point I'm going to get a relatively nice gradient value. I'll jitter the particles so you see better the volume. And I could also go and say I want to add an absolute value. So out A and then B creates an absolute. And now I have the whites on both sides and the black in the middle, and it's a nice gradient going on. But if I would open my outliner and select the p-sphere, the polysphere, and start, it turns out that the radius is actually 5.269 or something. If I start changing this value up or down, my gradient won't adapt. And it would be nice to do that. So originally, you could do that by going to this division here and adding floating points input, and then creating an expression connecting the radius of that sphere to this input value, so it would actually divide always by the right value. We improved on this in the last month since the original release of Magma, and now you can actually create a new property query operator. The property query requires a special input object node, so right now it's invalid. It says red socket means I need an input here. Some of the other nodes have defaults for their sockets and they're okay, but this guy doesn't know which object to use. So I have to drag from here, and when I release, you notice I get a menu that says the only thing that makes sense here is a new input object. I select from the menu and I have it. And all I have to do is click the polysphere, go to the property query, and I have the supported properties. I get the radius, I double click it or press this button here. I remove the translate because I don't want it, and now I'm dividing by the radius. That means if I go again to the polysphere and start changing the radius, the gradient will always be correctly fixed from 0 to the radius. If it wasn't a procedural object like a sphere with a radius, it was any arbitrary mesh, I could actually go and get the bounding box x-axis and use that, and it would work with anything. So this is new in my build, and we're going to post together with the videos of this webinar also the newest build of Magma, Krakatoa MY with Magma, that has the property query and input object nodes, and you'll be able to do those things. And as you can see, you can actually go and expose pretty much any of the attributes that you see. We still call them properties because the node was called property query in Max, and that's the name for attribute in Max, and we wanted to keep them in sync in both applications, especially if you start exporting flows from here and loading them in Max. We wanted to keep the same names of nodes, but property basically means an attribute.